right, let's go ahead and get going on this last unit of new material for Secondary 1. So in Unit 14, we're going to be talking more about data and statistics, but this time it's going to be two variable data and statistics. And we're going to start with a review of some stuff that you learned probably in 8th grade or sometime earlier. We're going to talk about scatter plots, and we're going to talk about lines of best fit. So 14.1, the I can statement is, I can interpret scatter plots and find lines of best fit. So we'll write the word fit right here. And then it starts off with a warm-up, two parts to this. It says, what is the slope formula when we're given 2 points? Well, the slope formula for 2 points is going to be m equals, it's y2 minus y1 over x2 minus x1. There's that formula. If we were given a graph, a lot of times we think of slope as rise over run. And then this one on part B, it says name each type of display. So if we look at this one right here, this one should look familiar. This is called a box plot. We've seen those before. We talked about that in the last unit. This one right here, we've got all these points that are kind of scattered all over the place. So this is a scatter plot. Hopefully you recognize that from before. This is actually, should look familiar, but you may not know the name of something like this. This kind of looks like a stock market ticker or something like that. The line's going up and down. This is actually called a line graph. So what's happening is they're just connecting a bunch of dots, and it may go up, it may go down, zigzag like this and stuff like that. And then we've got two interesting ones, both very similar. Remember, this one is a histogram, okay, histogram. And then this last one is a bar graph. And remember, the difference between a bar graph and a histogram is that the width of these rectangles and any gaps in between them really doesn't make any difference. This one is talking about guests and new users and existing users. The fact that there's a gap there or how wide those rectangles are doesn't make any difference. Now over here, if we look at each one of these rectangles, I bet these rectangles here are about 1 unit wide. So each one of those intervals or classes or scales, buckets, whatever you want to call them, each one of those is 1 unit wide. And if we had the one that was completely empty, what that would mean is that there's no values there. So we've got one right here. It looks like there aren't any negative values on there. And then, of course, the taller it gets, then the more data exists in that particular little interval. Now, there are lots of times when two numeric variables might be related, and some examples of this might be things like study time and test scores, height and weight, years of education and income, maybe the daily high temperature and the ice cream sales. There's a whole bunch of different times when two variables would be related, and that's where scatter plots come in handy. So what we're going to do right now is we're going to review some stuff that you learned in 8th grade, and just a warning about this entire unit and really data and statistics in general. It does take a fair amount of time just to explain how to do this stuff, but it's actually pretty easy. It takes longer to explain than it actually does to do it. So I'm hoping that almost everything that we do on example 1 is just sheer review. So example 1 says the table contains bivariate data. Now the word bi right there, that means two. So it's got two variables in this data chart right here. And it says it's comparing study time and test scores of 16 students. So over here, and I'm just going to write this off to the side because it's a good idea. We've got 16 students over there, and it says all data points have been graphed except for one, and it says put the data point 17,87 on the scatter plot, and then answer the questions below. So I haven't put 1787 on there. 1787 means 17 minutes of study time, and they ended up with an 87 on the test score. Now, you'll notice that somebody took the time to look at the data and scale the axis so the data is going to look good. So we can fit all of this data in here in the X direction, if you want to call it that, and then in the Y direction also. We've got a little broken axis there, so that's always an important thing to note. But what they didn't do is they didn't label the axes. So we've got tick marks on here, we've got a scale for it and everything, but they didn't label it. So we want to go ahead and label this so that we can put this point 17,87. Again, the 17 was study minutes, so I'm going to go to 17. That's going to be about right here. And we're going to put study time. And off to the side here in parentheses, we're going to put mins. And then over here, we're going to put test score. Now, I have a really hard time writing diagonally, or writing vertically, I should say. So I'm just going to write the name over there. Okay, so we've got this scaled, we've got it labeled, and then 17 minutes of study time, in this case, corresponded to 87% on the test, or a score of 87. So that's going to be somewhere about right there. So there's our 17,87. All right. Now, one reason we use a scatter plot is that they help us to see relationships that wouldn't be really obvious in the raw data. So this is what we call raw data over here. And it would be really tough to see whether or not there's a pattern, but if we graph these on a chart like this, on a set of axes, especially when it's scaled and labeled, then we can kind of start to see what's going on here. And it says, is there a relationship between the variables? Well, the answer to that is yes. And then it says, is there a general pattern? Well, yeah, there is. I mean, you can see that the more people study, the higher their score is. So it says, please describe your answers. Well, what we're talking about here is, let's just say it this way. The more you study, the higher your, and let's be specific here, the higher your test score, okay? So the more you study, the higher your test score is. And then it says when a scatter plot has a pattern that looks like a line, which this one kind of does, we can get a better idea of what the relationship is by finding a line of best fit, okay? Now, for right now, we're going to review what you did maybe in a previous class, again, probably in 8th grade. We're going to do what I like to call a line of pretty good fit, because there's nothing really scientific about this. There's nothing perfect about this. We're just going to come close. This is in no way a line of best fit. What we're going to do today is we're actually going to figure out how to find an actual line of best fit. So here's what we're going to do. It says use a data point on the low end and one on the high end to produce a line of pretty good fit. It says write your answer in slope-intercept form. I guess I should have a dash right in there. Okay. Use decimals to the nearest hundredth if necessary. Now, the reason we're going to use decimals here is because this is a real-world story problem, and it's just going to make things a little bit easier to understand. So when we say grab a point on the low end and a point on the high end, I'm going to grab this point right here, and I'm going to grab that point right there. And if I were to draw a line from here to here, it happens to go roughly, right by that point that we graphed 17,87, but this line would roughly approximate all these data points right here. I can tell that a line like this would not look very good. I can tell that a line like this would maybe have the right slope, but it wouldn't really go through the middle of that bunch of numbers or those points. One thing that you may remember is last year we may have suggested if you draw a circle that kind of tightly closes around that, and then draw a line right through the middle or something close to that, that's actually a line of pretty good fit. So that's one way that you can tell. But this low-high method actually works pretty well. So this low one would have been somebody that studied for maybe 1 minute and got about, in the low 70s. Well, that's this one right here. And then the one on the high end is somebody that studied for 30 minutes and they got, almost 100. So that's actually this one right there, just conveniently placed. So we're going to find the slope. So we're going to do y2. So I'm going to do this. I like drawing it this way. I'm going to do y2 minus y1. So I'm going to do 73 minus 99. And then I'm going to do 1 minus 29. So if I take out my calculator here, if I need that, if I want to double check, we're certainly welcome to. If I were to do this, I end up with negative 26, and I've got a negative 20, I apologize. This should be a 30, okay? So 29, I was thinking ahead to the answer. So this is a 29 right here. So we get a negative divided by a negative, and I am going to go ahead and grab the calculator for this part of it so that we can see what we get here. So I'm going to do, I've got a negative divided by a negative. I know that's going to be a positive. So I'm going to do 26 divided by 29, and I end up with 0.896. Okay, so this is one of those tricky ones where we've got to make sure that we're careful here. We usually round to 2 decimal places, so it's either going to be an 89 or a 90, and the way we tell is by looking at that 6. That 6 is enough to bump that up, so I'm going to write 0.9. Now, if you're one of those people who gets really technical, we're going to say the slope is 0.9. I have a hard time even saying that. Okay. Now, if I were to write that out, and remember, slope is a fraction, if I do 0.90 over 1, just to kind of emphasize the idea that we're going to rise 0.9 and we're going to run 1, we're going to go ahead and leave it that way for right now. And then I'm going to write down y equals, remember it's y equals mx plus b. But in this case, we already know what the slope is. We know the slope is 0.9. So I'm going to go ahead and replace that with a 0.9. Okay. Now, it doesn't matter which of these 2 points I grab. Each one of these is an xy pair. So I'm going to do the 1 and the 73. So I get a 73. So 73 right here. And then I get 0.9 times 1 plus b. So if I were to solve for what b is, I'm going to subtract 0.9 and subtract 0.9. So I end up with, I think this would be 72.1. Okay, so we get b equals 72.1. So here's what we've got. Y equals, I've got my slope right here, so 0.90. I'm going to put the 90 on there just for the heck of it. And then I'll put the x and then plus 72.1. Okay, this right here is the line in slope-intercept form. So that line that we did with a low point and a high point, it's going to roughly go through the middle of all of those points, roughly through that scatter plot right there. And that's a line of pretty good fit. It's a decent fit for the data. Again, it's not perfect. Now, it says, what do X and Y represent? So let's go ahead and take a look here and see what X and Y represent. There's a couple different ways that you can tell what's going on here, and I'm hoping this starts to kind of make sense of what's happening here. This is like the X column, and this is like the Y column. So X represents, well, gosh, look at this. It represents study time. So I'm going to come down here and I'm going to write X equals study time, and we'll put minutes here. So M-I-N-S, study time in minutes. And Y would represent, well, Y represents the Y-axis over here. It represents the Y values over here. It's the test score, okay? So Y represents the test score. Okay, now let's stop and think about this for just a second. We've got some vocabulary coming up here, and it says we call X the blank variable. We call it the independent variable. So we call that the independent variable, and we call Y the dependent variable. Now stop and think about this. Why would mathematicians choose words like this? And why is it really appropriate in this particular case that we call X the independent variable, and remember X is study time, and Y is the dependent variable. It depends on something. That's the test score. So stop and think for just a second. Okay, we're saying that the test score is the dependent variable and the study time is the independent variable. So independent kind of means you get to choose whatever you're doing and stuff like that. Okay, so the study time, you can choose your study time, but once you've chosen your study time, your test score is kind of determined. So we could say it this way. We'll say test score depends on study time. So that's actually a good way to think of this, and this is why they chose these words. Okay, this test score depends on how much you study. So once you've chosen your study time, your test score is kind of determined at that point. Now, again, this is a line of pretty good fit. This isn't perfect. This is a scatter plot. There's a lot of variation here, but this kind of gets us in the ballpark of the right idea. So I'm going to go ahead and enlarge this, and we're going to come down and take a look at the rest of what's going on here. It says the slope and y-intercept are important parts of the line of best fit, or the line of pretty good fit. And it says the slope represents how much the dependent variable, so remember the dependent variable is y, changes based on how much the independent variable, remember which one's the independent variable? The independent variable is x, based on how much x changes. So the slope represents how much the dependent variable y changes based on how much the x variable changes. So I'm going to come up here and I'm going to put the labels on this right here. Remember, when we do the slope, this is y2 minus y1 over x2 minus x1. So if this is the y on the top right here, if that's the test score, if that's your points, I'm going to write down points right here, and this is your study time, and that's in minutes because that's the x over here. So what the slope means is it's 0.9 points per minute. So we'll come down here, and that's what this next question is asking, is it's asking what do the slope and y-intercept mean for the study time and the test data above? Well, what the slope means is for every minute that you study, you get 0.9 points per minute, and I'm going to put per 1 minute here, okay? So that's what it means. For every 1 minute you study, you pick up an extra point, extra 0.9 of a point on your test score. And then we need to talk about the y-intercept. So the y-intercept represents the value of the dependent variable. So remember, the dependent variable is y when the independent variable is 0. So remember, when we're talking about the y-intercept, y-intercepts always have an x-coordinate of 0. So wherever that crosses right there, that would be the test score you could expect if you didn't study at all, okay? So I'm going to write that down. On this one, the y-intercept is 72.1, so you'd get a 72.1 points on test if 0 studying. If 0 studying. 0 study mins, okay? All right, so that hopefully is a decent review, and what this means is we can actually do a little prediction right here. We can actually predict based on how long somebody studies, we can come up with a rough estimate of what their test score would be. So if they don't study very much, they're going to get a fairly low test score, and if they study quite a bit, they're going to get a fairly high test score. But remember, this is just a line of pretty good fit. It's not perfect, it's not exact. We're just kind of taking a ballpark guess on this. And on the back side, we're actually going to learn how to find an actual line of best fit. So let's go ahead and take a look at that. All right, I've got the calculator up here because now that we've reviewed the basics of lines of best fit or lines of pretty good fit and the idea behind them, we're now ready to find an actual line of best fit. And the cool part about this is we're going to use the calculator to do this because the calculations that we have to go through, they're fairly sophisticated. They take a long time. They're pretty tedious. So I'm going to show you how to do this on the calculator. So here's the deal on this one. This is example number 2. It says the table and scatter plot contain data about absences per quarter and GPA for 10 students. So we could go through and we could take this and we could plot the data here. You'll notice that we can really tell that whoever made this knows exactly what they're doing because this is both labeled and scaled. So they've got the axes scaled and they've got the axes labeled. So I'm just going to write labeled and scaled. Always a good idea to label and scale your axes, okay? And then what we're going to do here is we're going to actually enter this data into the calculator. We're going to enter it into L1 and L2 using the stat and then edit, just like we learned in Unit 13. Now, I've got the calculator up over here so that we can go ahead and throw those in. So I'm going to go ahead and I'm going to hit stat and edit. So that's number 1. Now, you'll notice that I've already got a list in here. I want to get rid of that. We could reset the calculator, which is a good idea to do if you're using this in class and it's a calculator somebody else used before you. Remember, you can always go up here and you can hit clear. Please don't hit delete, and then hit enter, and that will get rid of everything. So we're going to put this in L1. So these are like the X coordinates for each one of these points, and these are like the Y coordinates. So I'm going to go through and enter these really quickly, but I'm not going to show all of it. So bear with me here. So I'm going to do 15. I'm going to hit enter, and then I'm going to do 0 and hit enter, and 0 and enter. And then I'm going to do a 10. Don't worry about that asterisk there. I'll come back when I get this all filled in. I've got all the data in there, and it's always a good idea. If you put the wrong data in, you're going to get the wrong answer. So always go through and just double check and make sure that you've got all the right data there. I've got 10 points. I did this earlier. I went through and double checked. So I'm in good shape. I've got everything in there. We're in business here. So again, one thing we want to look at is this is absences right here, and this is the GPA. So we'll notice that there's definitely a pattern here. So as the absences go up, the GPA tends to go down. So people with really few absences tend to have a high GPA, and people with lots of absences tends to be lower. Now, that's not a perfect rule or anything like that, but it's just kind of a general statement. So here's what we're going to do. We're going to do what's called a linear regression, okay? So we're going to grab this command right here. I'll show you where that is. It's under Stat and Calculate. Now, I'm going to show you what it looks like on an 84 right here. I do have what it looks like on an 83. It's very, very similar. Anyway, we've got the plots here. This is what we'd want to make it look like if we were going to draw a scatter plot, which we'll do in just a second. So over here's kind of roughly what you need to make those look like. So we're going to go ahead and we're going to do a linear regression. So I'm going to hit second quit, and we're going to hit stat, and we're going to hit calculate, because what we want to do is we want to calculate a line of best fit, and that's called a regression. We'll talk more about what regressions are later on in the unit. So when we come down here, I can either hit 4 or I can arrow down to 4, and I hit enter. Now, if you're on an 84, it looks like this. It says, tell me what the X list is, tell me what the Y list is, and by default, it's L1 and L2. You don't need to worry about the frequency list. You don't need to worry about store regression EQ. We want to come down here to calculate. So we're going to come down to calculate, and we're going to click on that. If it's an 83 or some other calculator that's not quite as advanced as this, all you do is pull that up, and then on the home screen it'll have something. It'll say lin reg, and then it'll do parentheses AX plus B. So we've got that on our screen right here on the 84. By default, it assumes that you're using L1 and L2. So all you have to do is just hit enter on that one once it's on your screen. On the 84, we've got to come down here and we've actually got to tell it to calculate. And I'll hit calculate, and here's what we get. Now, you'll notice that we've got a y equals ax plus b. If you happen to have some other stuff down below here, don't worry about that for right now. So when the calculator does this, instead of giving us y equals mx plus b, The B is the same. That's still going to be the y-intercept, but they use A rather than M. That's the only adjustment that we need to make. So you'll notice that where the A is, that's where the slope is, and it says A is negative 0.124. So again, we're going to round to, it says correct to 2 decimal places for this equation in C right here. So we're going to do 2 decimal places, so that's to the nearest hundredth. So this is going to be negative 0.12, so that's either going to be 0.12 or 0.13. That 4 is not enough to bump it up. So we're going to write this. We're going to write down y equals negative, don't forget the negative, 0.12x, and then the y-intercept is 3.78. So that's either going to be 0.78 or 0.79. That 3 again is not enough to bump it up. So we're going to put plus 3.78. Okay, so that is the equation. That is the line of best fit. Okay, very scientific, lots of calculations behind it. That's the one that we're going to use. And the cool thing is, it's kind of like a magic box here. The calculator did a whole bunch of work for us. Now, we're also going to do a stat plot here, and we're going to adjust the window to make sure that we can have that scatter plot show up. So that's going to look like this. So we're going to go to stat plot, so second y equals. We're going to turn that on. Now, I was playing around with this earlier, so this is what we need to make it look like. We need to turn stat plot number 1 on. Again, we've done box plots and histograms and stuff like that. We're on the scatter plot. It's the very first one. We want to make sure that the X list is L1 and the Y list is L2. It doesn't really matter what the mark is. By default, it's that first one right there. So once we make it look like that, we're going to adjust the window. Now, we've got a big help right here. Let's go from 0 up to, let's say, maybe 20 in this direction, and then let's go from 0 to 4, and maybe a little bit more than that. So let's adjust the window. So the x minimum is going to be 0, and I'm actually going to go, say, negative 2. Let's have a little bit of space on that side, and we'll go to 20. And the scale, let's make the scale in the x direction 5. So that'll match up with the tick marks that we've got over here. And then the y minimum, I'm going to go a little bit lower. I'm going to do -1. And then for the max, the biggest value we have up here is 4. But I want to make sure that I can see everything. So I'm going to do like a 4.5, and we'll put a tick mark every 1. Okay, so we've got 1, 2, 3, 4. That's going to put a tick mark in the y direction. The y scale is 1. And we've got a tick mark every 5 over here, so that's why the x scale is 5. Now, if we make a mistake and it doesn't look like this, if it doesn't look very good, then we can just go back and change it. So I'm going to check one more thing. I want to make sure that I don't have anything else. I'm going to clear that off. Get rid of that. Always a good idea to reset your calculator. I forgot to do that. Okay, so we've got the stat plot on. We've got everything looking good, so I'm going to hit second quit. And I'm going to, or I guess I could just hit zoom and let's see what it looks like. Okay, so that looks pretty good. Pretty good representation here. Remember, you can hit trace and it will tell you what point we're on. So it's flashing over here, and then we can hop over to the next one on the list. That happens to be right there. And it does go by the ones on the list, so it will kind of hop back and forth. There's a 10 and 3.1. So again, that means 10 absences and a 3.1 GPA. Okay, so we've got a scatter plot. It looks very similar to the one up above. And then it says use the y equals menu to enter the equation in step C above. So we want to go back to y equals, and let's put this equation in here. So let's put -0.12, and then we put the x. Remember, the x is right there. And then we're going to add 3.78. Okay, so it looks like we're in good shape there. And it says go ahead and graph this. So here's what we're hoping to see. Remember, last time we just kind of picked a high point and a low point and we drew a line on that front page. We're hoping that this looks really, really close to what's going on here. So let's go ahead and hit graph. And there it is. Now, you'll notice that it goes through maybe this point right here. These are all above the line and these are all below the line. So it doesn't really hit any points on our scatter plot, but it still looks pretty good. It looks like it fits that data pretty well. And again, if I were to draw kind of a little round blob around this, a little circle around that, it looks like the line pretty well goes through the center of that. So we're in good shape there. So it said graph the line and the scatter plot on the same graph. And then draw it on the plot up above. So I think we need to be just a little bit below here. So maybe about right there, and then about right there, and it definitely goes up above that one. So I'm going to make it look something like this. Okay, so there's our line of best fit. So I'm going to write line of best fit. Okay. Line of best fit. Now, it's not a line of pretty good fit. We won't go into all the mechanics and the calculations that the calculator did, but that is a line of best fit. Everybody would accept the method that we use there and the method the calculator employed there. Now it says define what x and y represent and say which is independent and which is dependent. So remember, x equals absences per quarter. So I'm going to make this a little bit bigger so we can write and see what's going on here. Okay, so x equals absences per quarter, or let's just say absences, and y represents, that's GPA, and it says which one is independent and which one is dependent. Well, the GPA depends on the absences. So this one is dependent, so dependent, and this one, the absences, those are independent. So if you can change your absences, then you can change your GPA most likely. Now again, not a perfect relationship, but we're just kind of making little predictions here and stuff like that. It says describe the relationship and the pattern that you see. So again, we've talked about this briefly already. It looks like the more you're absent, the lower your GPA. So more absences, I got a little too many absences, means lower GPA, okay? And it says, make sure you talk about what the slope and the y-intercept represent. So the slope, so I'm going to write down m equals negative 0.12. What that is those are change in GPA, okay, minus 0.12 GPA points for every, remember we could put this over 1, for every one absence, okay? So that means every time you're absent, that means your GPA is going to tick down about 1/10 of a point. Again, not perfect, but just kind of close. And then the y-intercept, let's see, remember the y-intercept would be this point right here, so that's 3.78. Let's see, so that means if you had 0 absences, you could expect about a 3.78, okay? So y-intercept, so I'll put y-int. That means 0 absences, means you get a 3.78. Now, that's just kind of a prediction. It's not perfect. We certainly didn't have any 3.78s here. It was a little bit lower than the 2 data points that actually had 0 absences. But again, this is just kind of a line of best fit. It's not a perfect predictor or anything like that, which brings us to our next point, and that is right here. It says, what GPA would we predict for a student who misses 10 days of school? Well, remember, 10 days of school, that's 10 absences. Absences are x. So what this means is, what is y when x is 10? So we're going to put a 10 right here. So y equals, this would be negative 0.12 times 10. Whoops, we put that in parentheses, times 10 plus 3.78. So I'm going to grab the calculator for this one and see what we come up with. So I'm going to hit second quit, clear this off, and I've got negative 0.12 times 10. I guess that actually wouldn't be too bad to figure out, okay? And then we're going to add 3.78, okay? So I think I've got everything typed in there the right way, and we get 2.58. So I'm going to put approximately 2.58. So we would predict that if somebody had 10 absences, they'd have about a 2.58. Now, I want to come back up here and take a look at this for just a quick second. We do have somebody who had 10 absences, okay? They had 10 absences and they ended up with a 3.1. In fact, you can see right here that this 10 absences would correspond to about a 3.1 right there. Well, the line is right here. What it does is it predicts about a 2.58, somewhere in that neighborhood. Again, my line's not perfect, especially the one that I drew right here. Okay, the important thing, and this is why there's an asterisk there, what we get out of a line is not going to be exactly matching any of these data points. In fact, we could have a line of best fit that doesn't hit any of the data points at all, okay? That's perfectly okay to happen. What we want it to do is kind of go right through the middle of them and be a pretty good predictor. Again, some are going to be on the high side, some are going to be on the low side. It might be an underestimate or an overestimate for some. In this particular case, it looks like for this person right here, they kind of outscored the model. If we would predict a 2.58, they got a 3.1, so that's pretty good. They did a little better than we would predict. Now, a couple things down at the bottom, and then we're done. We'll take a look at a couple of ideas, reminders from stuff we learned in 8th grade. So it says, really important to note, scatter plots almost never look exactly like a line. Very seldom does everything line up perfectly and everything's just great. Mostly what we're looking for is just the overall pattern and shape. And when there's a relationship between the variables, we've got a word for this, and we call it a correlation. So hopefully you remember that. This is a relationship. They're correlated to one another, okay? And the most common type of a correlation is a linear correlation. So the type of thing that we've been looking at, and there are two parts of a linear correlation. There's the strength and there's the direction. For right now, we're going to focus on the direction. The direction of a linear correlation can be positive, so let's write the word positive right here, or it can be negative. Now, it works kind of like the slope of a line. So if we take a look at this one right here, this represents a positive correlation. If the line of best fit goes up from left to right, then we call that a positive correlation. And we can describe the relationship this way. Both x and y do the same thing. So as x gets bigger, y gets bigger. As x gets smaller, y gets smaller. Now, a negative correlation is kind of the opposite. Okay, the line of best fit goes down from left to right. So it looks like this. Again, it looks like it's got a negative slope to it. Okay, and x and y do the opposite of each other. And what that means is this: as x gets bigger, y gets smaller. And as x gets smaller, the y gets bigger. So we pair big x's with small y's, and we pair small x's with big y's. That's why they do the opposite. Now, it is possible to have something that has no correlation. And what that means is the line that would roughly fit those, and again, we couldn't have a vertical line. That's not a linear equation, so to speak. It certainly wouldn't fit in slope-intercept form. Would look about like this. The slope would be roughly 0. So there's not really a pattern. We've got a small x that corresponds to big and small y's. We've got a big X that corresponds to big and small y's. So the size of x has nothing to do with the size of y. There's no relationship between the two of those. So let's take a look at a couple of problems right here. It says describe the correlation as positive, negative, or 0. Describe what it means in each situation. And on a scale of 0 to 100, how well do you feel like the line fits the data? Now, if you take a look at this, these are just miniatures of the two problems that we've already done. So this was the test score and study minute thing. We took the low and the high, and we did a line about like this. And this is the one right up above. So we had something, I think it went about like that. Okay. So again, we want to figure out, is this a positive, negative, or is there no relationship? What would the correlation be? So on this one, it would be positive, and on this one over here, clearly it would be negative because it goes down. And that would match up with the slope of this line's positive and the slope of that line's negative. And what we've got here is, it says the more you blank, the blank your score. So the more you study, so the more your study time, the bigger your study time is, the higher your score. So the more you study, the higher your score, okay? And over here, let's see, as absences go up, so the bigger your number of absences, the lower your GPA. So the more you are absent, the lower your GPA, okay? So this is that idea that they kind of do the opposite of each other when there's a negative correlation there. And then the last thing it says, how well do you feel the line fits the data? Well, if we looked at, I mean, this is pretty good, but we need to rate it on a scale of 100. And if I had to say, I think this one fits it a little better than this one right here. I think they both do a pretty good job. So I might give this like a 70, and I'd maybe give this like an 80 or an 85, something like that, 80 or an 85, okay? Maybe 70 or 75 on this, somewhere around there. Again, there's no perfect answer to this. So again, a couple quick things. It does take a long time to explain this stuff. Takes longer to explain than to actually do them, and you'll see that as we get started on the assignment. So go ahead and do the self-assessment, and we're going to take a look at problem number 1. Okay, so I've got the assignment up. This is 14.1, again, scatter plots and lines of best fit. It says use your calculator and what you know about scatter plots and lines of best fit to answer the questions below. So when we say problem number 1, you'll notice that we've got a graph right here, and then we have a whole bunch of questions about that. And then we get down to number 6. That finishes off the first graph, and then we start up with another one. So 1 through 6 all deal with this graph at the beginning right here. So what I'm going to do is, because we can use our calculator, I'm going to grab the calculator and I'm going to enter the data into this. So one thing we want to do here, and again, I made that mistake last time, so let's not make it again. I'm going to hit second memory. I'm going to hit reset. So on this calculator, it's a 7. I want to reset all the RAM, so that's a 7, a 1, and it says, do you really want to reset it? And I say yes, and then we're all set to go. So I'm going to go ahead and shrink the screen here so that I can see the calculator and the data. Now here's what this is about. This is about the vertical drop in feet of roller coasters built since 1988. So this is the years after 88. So year 0 right here, that would be in 88, and then 2 years after that, that would represent 90. And this is a very common thing to do, because then we don't have to start off with like 1988 and 1989 and so the numbers here can be smaller. We don't have to type in these gigantic 4-digit numbers here. I'm going to go ahead and type this in. And if you feel confident about being able to type it in, you can ignore me for just a minute, and then make sure you come back when we actually do problem number 1. So the first thing I'm going to do is I'm going to hit Stat and Edit. So hit the Stat button. The very first thing is number 1. And we're going to enter this data in. So I'm going to type in a 1 and a 3 and so forth. Okay, I've got everything typed in, and one thing we want to make sure is that we've got it in there the right way. So I'm going to make sure, I think I've got, let's see, 4, 5, 6, I've got 9 data points on this. So let's come over here and let's check. If I go down to the bottom of the list, all the way down there, so the 10th one is blank, we've got 9, and let's just double check. So we've got 15, 400, 13, 355, 255, 12, 255, that looks good. Got 12, 300, 12, 306, 8, 250. Always a good idea to double check here. It's well worth it. You're going to get really frustrated if you don't double check and make sure you've got the right numbers. So it says use your calculator to find the line of best fit and write it right here. Draw a scatter plot and line of best fit on your calculator, and then draw the line on the graph at left. So this thing right here we actually want to do just like we did on the notes. We actually want to draw a line here. So remember, this is how we do this. So I'm going to hit second quit. We know we've got the right data in L1 and L2, so we're going to hit Stat, and we want to calculate something. We want to calculate a line of best fit, and that's called number 4, lin reg, and then AX plus B. So I'll come down to 4, or I can just hit the number 4. On an 84, it comes up like this. On an 83, it just goes to the home screen. You can just hit enter there. So L1, L2, that's where we put that stuff. We can leave these other things blank. So everything looks good. We'll go ahead and get down here on calculate. We'll hit enter, and there it is. So on part A, it says write down the equation. So the equation, this is the slope. And notice we've got 13.852. That 2 is not enough to bump that up to an 8.6. So we're going to write y equals 13.85x, and then down here we've got 130.553. So that 3 is not enough to bump that up, so we've got our slope right here, we've got our y-intercept, so this is plus 130.55, okay? And then it says draw the scatter plot and line of best fit on your calculator. Again, really helpful to have this scaled and labeled for us. So let's go back here to second stat plot. We'll turn that one on. So we'll hit enter. We've got a scatter plot. It's L1 and L2, so we're in great shape there. If we want it to look like this, we want to scale it the same way. So let's go to Window, and we're going to start off at 0 because we don't have any points over here that are right on that line. So I'm going to go 0 all the way up to, let's say we go up to 16 because we've got this point that's a little bit past 14. So we'll come down here and do 16. We'll put a tick mark every 2 so it matches what we've got right there. And then we'll start off at, gosh, this is 50 and 100. So it looks like this is going by, starting at 0 and then going by 50. That would be the scale, but we need to go up to, I'm going to do a little bit more than 400 just so we can see that point right there. So let's do 450, okay? Don't need to worry about the X-res or anything. So let's go ahead and hit graph and see what happens. Okay, so that looks pretty good. You can kind of see this little L shape and these two that are right next to each other. Now, what we didn't do is we didn't draw the line of best fit here. So in order to do that, remember, we've actually got to put that equation in. So this is going to be 13.85x, and let's see, plus 130.55. And now we'll go ahead and graph. Okay, so it looks like it's a little bit below this one and then right below the two of those. So it's going to go about like, okay, that's not perfect, but we'll just have to go with it. Okay, so that's what the line of best fit looks like there. Okay, now it does want you on these other problems to figure out what the slope and the y-intercept represent. Remember, the slope is positive because there's a positive correlation between these. As the years go by, we get taller and taller roller coasters. You might think about, when we're thinking about slope, this is 13.85 over 1. You might think about, we put y's on the top and we put x's on the bottom. So think about, this is the x and this is the y. This is years and then this is feet. So that's the hint I'm going to give you. So good luck on the assignment. If you've got any questions, make sure you ask. This is fun stuff because your calculator figures out most of it. You just get to use your brain to do the interpretation. So good luck.